There's a difference between the exception and the error. So we should not confuse the word exception anytime with the word error. Now, what is error? Anything that is beyond the control of a programmer. If certain abnormal situation arises in a system, for example, your system runs out of memory space, or your processor suffers a crash, or your motherboard of a system encounter problem, or there is a problem with the input output devices, or there is a problem with the Visual Studio, or there is a problem with the common language runtime. Now, if any of these throw a problem, then me and you or anyone as a programmer who is doing a programming in C Sharp.net cannot handle it because this is beyond our scope. We cannot handle if Visual Studio gives us problems. What we'll do, we'll uninstall the Visual Studio and reinstall it again because we do not have a source code wherein we can modify the things, we can troubleshoot the things. So anything which is beyond the scope of a programmer, which he cannot handle, which he cannot troubleshoot, which he cannot sort it out on his own, we term it as a error. But beyond error, anything which I as a programmer or a coder or developer write in my program, it is my duty and responsibility to make sure that my code does not give a problem. That means the code is not vulnerable at the time of program execution. If at all it is, then I as a programmer bear that responsibility to provide an amicable solution to that problem. First of all, I as a programmer should not write any kind of a code which can give a problem at the time of its execution. That's my first primary responsibility. My code should be bug free and it should work flawlessly, seamlessly. And the end user of the program should never bear a problem. So for example, I have designed a project, I've installed on the client machine, client is using my project, and it's my duty and responsibility as a programmer that my program should run flawlessly. And that is why we have got software testing teams who make sure that the proper testing techniques are applied. Structural testing, functional testing, mutation testing, black box, white box. So many testing techniques are there, and the programs is thoroughly tested so that if at all any bug is left out, it should immediately be sorted out in the company environment itself. Rather than the end user or the customer telling to the company or to the team of programmer that see this is your project and it is giving me this many number of the problems. So what's my primary duty as a programmer? To write a code in such an environment that my program runs seamlessly fine. It does not give any problem during its program execution. And if at all I visualize that yes, my code can fall flat, it can collapse, it can break down, then I should provide a proper solution in the along with the problem. So what we normally do in exception handling, we write such vulnerable code in the try block. Try means just try it once. And if at all my code in the try block suffers a problem, immediately it will look out for a proper solution. So immediately after the closing curly braces of the try block, we write one or more than one catch block because we really do not know the problem which has just arisen. It may have a one solution, it may have many number of the solutions. So which is the most appropriate solution for a given problem? So that corresponding catch block will get executed. So we can write one catch block or two catch block or three catch block or four catch block. But at any given point of time, when exception is thrown from the try block, only one catch will execute. Though we can write multiple catch, but only one catch will execute and multiple catch will never ever execute. That is something which we need to remember. Writing multiple catch does not mean all of them or maybe more than one of them will execute, but only one will execute depend. And which is that one which is most appropriate to the problem that has just arisen within the try block. So me as a programmer or you as a programmer cannot identify that the catch number 2 will execute, or catch block number 4 will execute, or catch block number 6 will execute. It depends upon the CLR, common language runtime. It will decide that based on this problem, or when the code got collapse, or when the code gets breakdown, so which is the most appropriate catch block, it will automatically get executed. But if I'm not sure that which is the most appropriate catch block, so right in the last catch block, I should make a call to superclass of the exception, what we call exception. Just writing the exception is a superclass exception in the entire hierarchy, and that will handle all the exceptions. But that should be the last solution and not the first solution. Means right in the very first catch, I should not make a call to the superclass exception, but in the last, I should make a call to the superclass exception. In between, I should try to handle on my own. Now, since we are able to handle this problem with the matching catch blocks, we call it as an exception handling. That means as a programmer, I can handle the exception which has been thrown by the lines of code written in my program. But since we cannot handle the error, we never say the error handling. In the books, in the literature, you only find exception handling as a name of the chapter or name of the topic, but not error handling, because we cannot handle the errors. They are beyond my scope as a programmer. But yes, I can handle the exceptions. So that is why we use the word exception handling. Now, how good you are in exception handling, that depends upon the programmer. So when the programmer starts his life in the industry in the initial 1 or 2 years, he does not visualize the problems because he has less experience. But gradually, when he grows up the industry, meets the customer, carry out frequent customer interaction, he realizes what are the problems the customer can face in the real time. So he writes a code in such an environment that code rarely breaks, rarely falls flat. So exception handling is such a phenomenon which improves with the passage of time, because no programmer will write a bad code. Every programmer who is earning, where a company is giving him a salary, he will make his level best that he should write a code that works absolutely fine without giving any problems as such. For example, now let's see the code that will make the things much more clear, and we'll keep on discussing along with it. So we write a class exception, we define a main function, and we print a statement, please enter the index of the array element which needs to be fetched. So we have defined an array, we prompt the user to enter the index of the array element which he needs to be fetched. So he will provide us the value, and we already know in C#.NET when we receive the value, it will come into the string. So we need to do typecasting from string to integer. And for that we make a call to toInt32 function of the convert class. So console.readline will receive the input, convert it into an integer, and store into an integer variable called number1. Now we come to the try. Now when to start try? That is another challenge. Now every programmer has to visualize this thing, that whenever he is writing a code which can create vulnerabilities at the execution time. For example, in this case, the user may enter the index which is beyond the scope of the array. So what should I do? I should be ready with a catch block or the catch clause, wherein I define a reference variable of the exception class called index out of range exception. So already the exception class is available. I instantiate it, and if at all the problem arises, I display the same problem. So console.writeline parenthesis e. So the programmer can sort it out, what is the problem which has arisen. Now here this is an array, and it is containing 5 elements: 0, -1, 20, 33, 40, 50, 6 elements are there. And let's say user enters. So here we define an array by the name ARR, and it is currently containing the 6 elements. Now if the user enters the index value which is beyond the size of the array, in that case the exception will be thrown. However, if he enters the right value, right index value, then whatever is the value present at that index position in an array, that will be fetched and it will display to the user. But then we have a limitation in the size of the arrays. We can't define the arrays which are infinite in size as such. For that, we have got a dynamic arrays, and we need to use a dynamic array which expand in size as you keep on adding the element to it. Just like in Java, we got vectors. Vectors are dynamic array which keep on expanding their size as you keep on inserting the element into the array. But here the size of the array is fixed. So moment the user enters the index position, we fetch the value and we display it. However, if he enters the index position which is beyond the size of the array, then immediately the exception will be thrown. It will be handled by the catch. So we got index out of range exception, and we will display the appropriate exception to the user. Now finally block is something which will always get executed irrespective of the fact that whether exception is thrown or not. But finally is always written along with the try. So we cannot write the finally as a standalone aloof block. It is only written once you have written a try block. So after the try, either you can write a catch immediately after the closure of the try block, or we can write a finally block. Difference between the catch and finally: catch will be executed only when the exception is thrown, but finally will always get executed irrespective of the fact whether exception is thrown or not. So what could be the primary conditions that what could be the lines of code which I need to write within the try block? First things first, let us say whichever code accepts the input from the user. Such a line of code should be written within the try block, because we cannot predict what the user will give us the input. We are asking him to enter string, he can enter the numbers. When we ask him to enter the numbers, he can enter the string. When we ask him to enter mathematical operations, he just enter the alphanumeric strings. So we really do not know what kind of input the user will give to us, because he will use his own. And there are users, there are good users, there are bad users, any kind of users are there. So when we write a program, our program should be able to handle these things. Whenever we receive an input from the user, that line of code explicitly should always be written within the try block. It's almost mandatory that we should do it at such a manner. Let's take a simple example. We all go to the ATMs to enter the debit card and credit card for swiping, for withdrawing the money. Now that has got the MICR, magnetic ink character recognition, that scans the magnetic strip of our ATM cards. It also got the small chip which reads our information about the card. Now, when we insert the card into the ATM machine, the card expects that the MICR strip will be there and the chip will be there. Now, I don't insert a ATM card. I insert my, let's say, college I card, because it has also got same dimensions. Or let's say Metro card. It has also got same dimension as the credit card. Now the code of the credit card software which is installed on the ATM machine will fire. Now it expects the magnetic MICR, magnetic ink character recognition strip will be there, or the chip will be there, and it is not there. You have got your barcode on the back of your library I card, which is your college I card. So the code of the credit card is working, but it is not receiving the desired input. So in this case, what will happen? Immediately the exception will be thrown, and we should prompt the user to re-enter the card once again. But let's say the user is adamant. He keeps on entering the same card again and again and again and again. And if the code gets flat, if code gets broken up, then immediately we can see a blue color screen comes. That means the code has broken up, the code has fallen up, and it was not able to handle the current situation which has been created by the user. So what is the most appropriate solution in these scenarios? The guard of the ATM will come, he will restart the machine, because that's the most wonderful solution in the IT industry to all the problems of the software and hardware. Whenever your machine creates a problem, whenever software creates a problem, give it a small amount of time to recuperate on its own, to revive on its own. If it does, good. If it does not, restart the machine. Assuming it that the problem which has arisen last time will not arise again, because that's the assumption we make every time we go for a restarting of the software or the restarting of the hardware. So point I'm trying to say, whenever we receive the input from the user, we really do not know what all he can provide us as an input. That is why when we go for the designing of the GUI based software, maximum thing we do it with the help of the list box, combo box, radio buttons, check boxes. Only when we prompt the user to enter his name, then only we give a text box, so that he does not give us the rough values. When we want to enter his age, we will say, this is the list box, choose your age. So he will choose one of those age. Then we want to have his qualifications, so we'll give a check boxes 10th, 12th, BTech, MTech, MCA, MTech, PhD. He will just check one of them. So we will not ask him to enter his degree. He can enter any kind of degree. So we want to limit his scope, that we whatever we ask him in the software, only that value he should provide and nothing beyond that. So that is the condition number one when we write the code within the try block. Second is whenever we go for, let's say, database connectivity. I'm trying to connect my Java C Sharp C Sharp .NET program to, let's say, MySQL Server or Oracle or Sybase, DB2, PostgreSQL, to any kind of database. Now, there could be a problem in connection of my program to the database in terms of drivers. Drivers may get loaded up, they may not get loaded up, or interruption can occur between the front end and the back end program. Maybe at my code or at the software level, maybe Visual Studio or the Eclipse from which I'm trying to connect to the back end, or could be at the operating system level, or maybe at the database level. Somewhere some problem has arisen. So whenever I'm trying to connect my front end programs to the back end database, I need to make sure that I write this program within the try block. For example, if you remember the Java which you would have done in the last semester, when we write the JDBC code, and we go for the loading of the driver, we say class dot for name, then within parentheses within quotes we write sun.jdbc.odbc.jdbc driver. So we are loading the driver, we are carrying out the registration of the driver. Now that part need to be written within the try block. If I'm connecting to the MS Access, or if I'm connecting to the Oracle, so I will say class dot for name oracle.jdbc.driver.oracle driver. So I'm connecting, I'm first of all I'm loading, registering, and then connecting my front end program to the back end databases. So such a type of the code which can create problem in the runtime, I need to write within the my try block. Another scenario where let's say file handling. File handling is another situation where I need to make sure that the code where you are trying to open a file, you're going to try to write into the content to the file, then you are going to close the file, send the file over the web to the destination, then the recipient will receive the file, open it up, read the content of file. So such a kind of the code where we write the file handling, like in Java we got the readers and writers, stream handlings is there. So it is always advisable such a kind of code is written within the try part. So all these, there are multiple situations, like in the operating system we have also got inter-process communication and synchronization aspect, wherein a single shared resource is being accessed by multiple number of the parties, multiple number of the programs as such. Now, I need to make sure that my shared resource is properly managed among the multiple programs. Otherwise, all of them will try to get access at the same point of time, and that can create a problem. So, what I expect every program to come, acquire a lock on a shared resource, use it, the shared resource, and then when he is done, unlock the shared resource and go back. So that is what we call when we move towards inter-process communication and synchronization, because that is where we handle these kind of the phenomena. So it is my vision as a programmer that I need to visualize. Nobody will tell me you, because I am writing my code. I need to make sure that my code properly works fine. Otherwise, it is likely to fall flat. It can create a problem at the runtime. Now, testing team will try its level best, that they try each, they just like what we do in we create cycle, we do program graph, we create every branch of the, it is tested. But at times it may happen that sometime there could be a portion of the code which left goes untested or not properly tested. Now such a kind of code can create a problem during its execution. So as a programmer, again I need to visualize that what are the appropriate lines of code I need to write within the try block. And again, since I am writing a code, I should be able to visualize that what is a problem that my code can create during its execution. So I should be ready with all such kind of the solutions within my catch block. But again, at any given point, only one catch will execute, not multiple catch will execute. So that's why we use the word exception handling and not error handling. We cannot handle the errors. That is something that should be clear in our mind. So finally, will it get executes a small simple program? I should don't think there should be any problem in that understanding of it. Now there are various predefined exception classes that is provided to the programmer. Like we got array index outer bound exception, or let's say arithmetic exception, wherein let's say you are trying to perform certain mathematical calculation and you receive a number as an input from the user. You put it into a numerator, and denominator is coming somewhere from the program from the top, and you try to divide that numerator by denominator. Now that will create a problem. So what if wherever the user makes an entry, we should be able to successfully able to sort out that code where whatever he makes an entry, we check whether the number is valid or not. Only if the number is valid, then we go ahead with the division part where we divide the numerator by denominator to get the appropriate result. So there are predefined exception classes I can use, like index out of range exception, array index out of bound exception, arithmetic exceptions, then memory out of stack exception. There are predefined exception classes which have been provided both in Java and C Sharp. And if your code throws an exception which is beyond these classes, then right at the last line of the catch, we can write the except. We can make a call to the exception class which will handle any kind of the exception. Whatever code you have written, that will be handled by the exception classes. So we execute the program, and are we able to see the command prompt window? Or let me do the stop sharing and then reshare it again, the entire screen. So we execute the program. Please enter the index of the array element which need to be fetched. Initially, I enter the right value as 3, and it gives me the value 33, which is present in that position, and finally block also gets executed. I re-execute the program once again, and this time with a wrong value. So let us say I enter the value as 10. And then it throws the exception system index out of range exception index was outside the bound of the array, and finally block again will always get executed. So in this way I will be able to execute the programs using the exception handling. Now right, if you look at the top right at the starting, we'll have the system namespace or system.io. Now system.io is something which we have not used as of now, and this is a namespace exclusively provided for the file handling part. So this is something which we have to include, which we have not used till now. So using system.io. Then we design our own namespace by the name, let's say my application. Then we define a class by the name program, and then we define a main function, static void main string args. And these are the multiple function which we are going to call. So what we do first, we go and instantiate the class. So we have program P1 is equal to new program, and now we get a reference variable of P1. Now with the help of P1, we will make a call to the multiple predefined functions already available to us in the system.io namespace. Now C Sharp.NET provide them as a predefined function. So APIs are already there behind the scene. Visual Studio has already included those API in IDE. So ready-made functions are available. We don't have to write our own long codes, just like we used to write in C and C++ for file handling. So just like Java, here also many functions are predefined, and we can directly make a call to them, and perform the required operations. So we can go and write the file, read the file, append the text to the file, again read the file after appending the text, copy the file, and maybe replace the file also. So multiple number of the predefined functions are already bundled in or packaged in, and we can make a call to them and then use them in our own program. So first of all, we make a call to the write function, right? So write, as the name itself indicate, we are going to write certain data into the file. So we prepare that data. So we say string write text is equal to Delhi is a capital of India. Now either we can accept the input from the user, that is what we could have done, or we can hard code the text anyway, whatever is comfortable, we can do it. So here we have hard coded the text Delhi is the capital of India, and we would want to write the text into the file. So what we say, file dot write all text. Now write all text is already a predefined function, and these are the parameter declaration, the prototype of it, string path, comma string contents. So, and the exceptions, these are the possible exceptions which will be thrown by it. Argument null exception, path too long exception if you give an invalid path, directory not found if you give a wrong directory, IO exception, unauthorized exception if you don't have privileges to access that file, and not supported exception. So many number of the predefined exceptions are already available for us. We can make a call to them, or we can do the try catch part. We can write this line in the try part, and then catch, we can handle all these exceptions which I've just shown as a part of tooltip. Now what we do, the first parameter says go and have the file. So we create a folder called C sharp, and within it we have the file 1.txt, and we make a call to the write text. Write text is already declared at the previous line, which is containing the string. So a file is created by the name file1.txt in the C sharp folder, and the text is written into the file. And if it is able to do it, we say console.writeLine data successfully written. That means the data has been properly written into the file. Now once the data is written, I can write a code to read the content of the file. So what do we do? Now we have got the entire path there in place. So C sharp file1.txt, and we say if file.exist, means if the file is actually existing at that particular location. So we pass the location within the parenthesis to the exist function. So exist function, with the help of the operating system, will check that whether the required file is present on the specified folder on the C drive or not. If it is not, we can go to we can throw the exception if we want, or if we can come to the else part and write that file does not exist. If the file exists, then now we can go and read the content of the file. So we say file dot read all text. Again, it is a predefined function, read all text, and this is a prototype of it, string path, and multiple exception likely to be thrown by it. Argument null exception, path too long exception, directory not found, IO exception, unauthorized exception. So multiple exceptions are there, and we can handle them. And this path is passed as a parameter str1. So all the content will be read from the file and stored into a read text variable, and then we can display the content of the read text variable back to the user. So this is a small code from the line number 19 to line number 33 that deals with the creation of the file, writing the text to the file, then reading the file, opening the file, and then reading the content of the file, and then displaying the content back to the user. Now let us only execute this much portion of the code, right? So what we do, we make the other function as comment entry as of now, so that they are not called, right? So we only have got two functions right now, write and the read. And then we go and just execute the program in its current state. We don't do anything, we'll do something more, but that we'll do later on. Let's execute the program as it is. And now we can see it has thrown the exception. Why it has thrown the exception? Because it searched for the folder C sharp. and file1.txt, which could not be found, which could not be tracked, which could not be located. Now if you go to the root drive, which I hope so it is visible, on the C drive we do not have any folder by the name C#. Now what we do here, we create a folder because that is what was required, but I wanted to show you the exception that will come. Now we create a folder C#, right? Now we go back to the Visual Studio and click on continue, and then again run the application. And now we can see on the command prompt window it has shown data successfully written, and data was written into the file, file was found, file was opened, and the data was read from the file and displayed onto the command prompt window. So Delhi is the capital of India. So now we can go back to the file.
Command window is not visible.
Command prompt window is not visible.
Only code section is visible, sir.
Okay. Let me share the complete screen once again. So I re-execute the program once again. And let's name the file as file2.txt. Run the application. Is it visible command prompt window now?
Yes, sir.
Okay. Now it says data successfully written. Delhi is the capital of India. That means now file has got created, data has been written into the it, file has been found, file has been opened, and then content has been read from the file and displayed back to the end user using his command prompt window. Having done that, now we go back to the C drive and see the content of the C# folder. Is it visible C# folder?
Yes, sir.
Anyone can say quick yes or no?
Yes, sir. Yes,
Right,
sir.
right,
It's
right.
visible.
So we have just created the file called file2.txt, right? So we see the file2.txt and we open it and we can see the content of the file2.txt. Delhi is the capital of India. So that means data got successfully written into the file, and data was also read from the file. Now we do something more. Now let's uncomment one more functions, append. So that can be called by the CLR. And again we read the content of it. Now we move on and we come to the append function. Append, we already know the meaning of the word append. The data will be written into the file already, and the file pointer will move to the end of the file, and whatever are the new contents, it will go and append to the already existing content. So no content will be overwritten, but the previous content will be appended or added with the fresh contents which will be received by the from the user. So in the append function, what we do, we write the name of the university. So a string append text and GGSIP university. And there's already a predefined function called append all text. So file dot append all text C# file1.txt, or we can write in the file2.txt, which we have just created. Okay, we have just a file1 only. So because right at the top, everything is fine. Delhi is the capital of India. That's fine. Read function. File. Okay. Here now we have a problem that file2 here will also read from the file2, so that consistency is there. And then we append into the file2.txt. Now everything we are dealing with the file2. So we display the GGSIP University. We append the content of GGSIP University and file dot append all text C# file2.txt. Now we can stop the previous output of it, yeah, and then we run the application. Now it says data successfully written. Delhi is the capital of India, and now the content GGSIP University has been added to the content of file2. The file2 was opened, and then the content were again fetched. So we can close it down now. And so we have executed the function write, read, append, and read. Now, the beauty of this entire C#.NET file handling, these programs are very simple, they're very small, and whenever you want to make a call to any function, what you need to do, just write file, and then you can see multiple number of the predefined function available, which can be called by the programmer to perform multiple operations within a file. So IntelliSense compiler will invoke and it will display whole many number of the function which are available, which can be called. So I have taken few of them for discussion, but yes, depending on the requirement, many functions are available. It can be made called, and then you can pass the desired parameters and also do the exception handling. Now, since here I was a writer of the file, I was a reader of the file, so there was no need for exception handling. But if the same program will be shared with the user or with any of the other team members, then I will do the proper exception handling, because they need to check whether the file exists or not. If the file exists, then only they can read the content into the file. But since here I am doing it for my own self, I have just written the content and I have read the content without any problem. Let's discuss another one more function, the copy and the copy function. And let's also discuss the replace, because they are almost similar in their functionality with added features. Now, public void copy, we make a call to copy function. So file.copy C# folder file, we are dealing with the file 2, so we'll get file2.txt and we create a new file. So it will copy the content from the source to the destination. So copy the pick up the content from the file 2.txt, create a new file, and then store the content into the file5.txt. You can give any name from your own choice. So it will create file5.txt, take the content from the file2.txt and copy it, means place the content, and then we say file successfully copied. Let's see this much before we go for the replace, whether it fires the function copy or not successfully. So we go and launch our console application, and it displays the message file successfully copied. That means the copy operation works successfully. We can go to back to the C# folder. So we can see the file 5 here, and it contains the code Delhi is the capital of India with a GGS IP university written inside it. So file copying operation was successful. Now, after having copied the content of the file, what if I want to replace the content of the file from one file to another file? So for that, we have got a ready-made function, a replace. Let's uncomment it right at the top so that can be called by the CLR. And we come to the function called replace. Now it says file dot replace. Again, if you look at the prototype, it says string source file name, comma, string destination file name, comma, string destination backup file name. Now first is the source file name. That's perfectly fine. Then where you want to copy it, I say copy it into the destination file. Now if the destination file name is not found, then we can have a backup of the destination file name also. So we can have three parameters in the replace. So how do we use it? Simple, we make a call to a function. So C# file1.txt, then that's the first parameter, then comma, second parameter, C# file99.txt. And if the file 99.txt is not found for any of the reason, then it will have a backup of the destination file. So C# file 100.txt. So these are the random names I've given to the file. You can give any logical name also from your side. That's not a problem. But file name should be right, so that the CLR does not have a problem in handling at the execution time. So when finally we say console.writing file successfully replaced. So since we are dealing with the file 2, so I write file2.txt, C# file99.txt destination file name, and then the file 100.txt. So I have already uncommented it at the top. Just let me check. Yeah. So we close down the running console window and then run the application. Yeah, now copying it will create a problem because it has already performed the copied operation once. So what we need to do, either we comment the copy function or let's create another file so that this line of code does not give a problem to us. So we can close down this running command prompt window and then rerun the application. Now it says unable to find the specified file because what we have to do now, we have to create this file 99.txt and file 100.txt, because if we do not create, then it will not be able to replace the files. So it becomes our duty that we need to create this file, otherwise it will throw the exceptions. And it says the exception clearly, system.io.file not found exception. Always when we deal with exception handling, the first alphabet always remain in the uppercase. So what we need to do to make sure that the function works successfully, we create a new file, 99 and then the 100, right? And file 6 we have not used, or rather we'll keep another name. Why to make it much more complicated? So we close down the exception part and we close down the running command prompt window. And let's give another name, file7.txt, so that copying operation does not create a problem. And now almost all our files are ready. Now we can click on the console app and we can see now the command prompt window. Data successfully returned. Delhi is the capital of India. So first line shows the write function is successfully fired. Second line shows the read function is successfully fired. Third line indicates that the append and read function is successfully fired. Then fourth line indicates that the copied function is successfully fired. And the last line indicates that file has been successful. Copy and replace operation has got successfully fired up. So we created two files, 99 and 100. Now we can go back to the uh, drive and now we can see, have a look at the content of the file. So we open the file 99 and we can see that the data has been written into it. Delhi is the capital of India, GGSIP University. So content was fetched from the file 2.txt and written into the file 99.txt file. And we also go and check the content of the file 100 and we find file 100 is all blank because this was a destination backup file name. If the file 99 would have not been found, then the content would have been written into the file 100. That's how the replace operation works. So these are some basic fundamental operations of the file handling, and not much to be discussed. All functions are very simple, and whichever function you would want to make a call, just take the help of the file, press dot, and IntelliSense compiler will invoke the list of the available functions. All of them are predefined functions and you can make a call to them. The prototype is available. If something what we need to remember, that prototype we need to follow means pass the required parameters, otherwise it will throw the valid exceptions. So this is something which we need to remember while dealing with the file handling parts.
Sir,
Yeah,
sir, in the append function,
have the good knowledge of the referencing part, how the objects are created, how the class are instantiated, to have a good working knowledge for the delegates. So delegates are similar to the object references but are used to reference methods instead of the objects. Now that's a fundamental difference when we move from C++ towards a C sharp. And three properties have been provided in C sharp.net for the delegates. First is they talk of the type or the signature of the method. So we're talking of the prototype of the method that the delegate can point to. So delegate will point to the method and will keep a track of what is the type or the signature of the method. For doing it, we will also carry out something called forward declaration. which we have not been doing in the other C# program, but here for the delegates, just like if you remember in C also, and in the initial part of C++ also, we used to carry forward declaration of the functions before we start using them. So here we'll carry out the forward declaration and before we start using it. The delegate reference, which can be used to reference a method. So we'll create a reference of the delegate, and it will be used primarily to refer to a method and not to the object of a class. And the last basic feature of the delegate is actual method reference. So we'll create a forward declaration and we'll try to refer to the actual method using a delegate. So overall concept, if you try to summarize, we will not talk of the classes, we will not talk of the objects, we'll talk of the delegates, which are actually pointing to the methods of that particular class. If you remember, code is similar to the concept of what we used to have inline functions in C++. Uh, we used to have the cout statement, and then we used to write the name of the inline function, and the control was transferred to the inline function, then the body of the function got executed. So here also delegates are known more by the delegate name rather than the inline function name. Now if you look at the code here, system namespace usit, then class delegate1, then we carry out a forward declaration in the line number 6. So we are going to create a delegate. The scope, the type will be delegate only. So this delegate is a keyword. Then we specify two parameters which it will receive, int a and the int b. Then we come to the main function. Then what we do, we instantiate the delegate. So my delegate md is equal to new my delegate, and we pass the name of the function as a parameter to it. Now this function has been defined outside the body of the main function later on. Then we make a call to the MD. What is the MD? The reference of the my delegate, and pass 3 and 4, the two number as a parameter to it. Now from where will this number go? If you come to the add function here, add int a comma int b. So we'll receive the value 3 in a, 4 in b. Then we add the two, return a plus b, value will be returned, and we are already holding on to the return value into a integer variable called r. And then we say console.writeLine, the result of the addition of the two number is, and then we display the value of the r variable, which is the integer variable, and the r is already being placed here as a placeholder. So value of the r will get placed in this the first curly braces, where we have got the index position as 0. Now if you just see the execution of the program to understand it in a better way, it says result of the addition of two number is 7. So it is able to add the two numbers 3 plus 4, and it is able to add the to it and display the result back to the user. So something which we need to remember here, the important lines. First of all, we need to have a forward declaration of the my delegate, which we don't do for any other classes in C#. So this is the delegate which I am creating, and then this is the same my delegate here which I am instantiating. So my delegate md is equal to new my delegate. Now what it will receive, normally what we do, we make a whenever we instantiate a class, by writing parentheses we make a call to the constructor of the class, maybe parameterized constructor or the no argument constructor. So any type of constructor we make a call, but here we will not make a call to the constructor, we will pass the reference of the function. So which is the function add. So we pass the reference of the function add here. Now md is a pointer, it is pointing to add function, because this is a reference variable. We don't call explicit pointer as pointers in C#. Explicitly they are used by the C#, but implicitly we don't. Implicitly they are used, but explicitly it is not given to the user to use it. But MD will behave. We know it's all reference variable behave like a pointer. So here MD is actually pointing to the address or the location of the add function. Now we using this MD, we make a call to the function which is being pointed by the MD, and that is the add function. So we pass the values here 3, 4. Now the add function will trigger and it will receive both the values 3 and 4, add them up and return it back. Right? Now here our integer variable r is ready. and then the values comes and gets stored here. The final value is 7 after the addition of two numbers, and we are able to display it back to the user by writing a console.writeLine statement. The result of the addition of two number is, then the placeholder 0 within the curly braces, and then the name of the integer variable, which is r. That is how the delegate works. But literature shows we do